So
Mhm.
those are the sorts of like really core skills. Do we teach that in school? Is that something that you can go to university and study? This is what makes this shift so interesting, that a lot of the skills that appear to be becoming very critical are things that you mature into. And that's where my conundrum is. How do you teach those? How do you short circuit that experience-based, deliberate practice learning process?
First of all, if AI is producing the code and we review it, what's the fun in that, Annie?
Yeah, that's a really great question. And you're right, we don't make great reviewers.
You're listening to the AI Native Dev, brought to you by Tesla.
Hello and welcome to another episode of the AI Native Dev. Joining me today is Annie Vella, and Annie is a distinguished engineer at Westpac in New Zealand. And I loved a story that Annie and I just shared when off air, whereby it was 6 years old Annie was when she built her first computer, which was a Commodore 64, which was wonderful. And that really kicked Annie off into the engineering world. Annie's got a very large engineering background from an half IC, half engineering leadership, and actually also doing a part-time master's exploring the impact of AI coding assistance in software engineering at the University of Auckland. Annie, a massive welcome to the AI Native Dev. How are you?
Thank you very much, Simon. I'm great, and I'm very glad to be here speaking with you today.
And you're in New Zealand, so it was a little bit tricky. A little bit tricky finding time for the recording, but we'll
Yes.
let the viewers work out whether it's AM or PM, your side and my side. But we're 12 hours, exactly 12, no, sorry, 11 hours, I think, apart.
Yeah.
Yeah,
Yes. Yeah, every time I
awesome.
have to try and schedule something with somebody overseas, it's a matter of using any tool possible to work out that time difference. It's quite
Absolutely.
frustrating.
Oh gosh, time zones are hard. So we're talking today actually because of a wonderful blog piece that you wrote. And I think it's one of those things that will absolutely resonate with our audience. Your blog is titled The Software Engineering Identity Crisis. And from our point of view, we're thinking a lot of the similar kind of concepts of how our roles and software engineering in general will change with the introduction of AI coding assistants and becoming more of a driver in the world of software engineering. Why don't we start? Perhaps tell us a little bit about the blog, the summary of the blog, the high level view of what you covered.
Sure. I guess it starts with the fact that I have, like you mentioned, been a software engineer in one way, shape, or form for a very long time. And I've absolutely loved it. I've loved being a coder, I've loved being a problem solver. And, with this introduction of this new amazing technology, which it just feels like magic, one can't help but wonder, okay, what is that going to do to the day-to-day job of a software engineer? And it's exactly the same reason why I chose to do that as a master's topic. But I've been digging deep into really what's driving me to ask these questions, right? Is it because I want to help design better AI tools for people to use, or is it because I guess deep down inside, I fear that we might be losing something, the thing that attracted me and many others to becoming a software engineer in the first place? And I've been writing a bit about the journey and learning how to use these tools. And I've been using Windsurf. That's probably my go to at the moment, aside from ChatGPT. But for coding, Windsurf, I find it incredible. I've written a bit about that, but I really hadn't gotten to the root of what I think about a lot, what I like talking about, what I'm trying to really get to the bottom of as part of my master's. And it came down to there's a lot of productivity gains to be made with these tools. Yes, our roles are changing, but at the core of it, we're losing something as well. And a
Mm,
lot of us, software engineers, we've tied our identity to the work that we do. We're very proud of the code that we write, of the solutions we come up with. And that very much depends on what stage of your career you might be at. But certainly in those formative years when you're learning how to code, how to structure your code, how to find the bug, how to fix it, you're actually refining those skills through practice. And if now we're delegating those to an AI, to a tool, then you're not going to get to practice those things anymore. And so you're not going to be necessarily forming those skills, but you might also not be doing the thing that you enjoy doing the most. I reflect on my years as an IC and also all the time that I've spent coding in my spare time, because we also do that, right? That moment when you get into the zone, and sometimes we call it flow state. We might refer to it in different ways, but it's that moment when you know what it is that needs to be done. You've solved the problem in your head to some degree, at least you have a path. Maybe you got some good music on. I know for me it was always like in these big headphones with good fun music playing that sort of drowned out the rest of the world. And then it felt to me like I was playing the piano. Like
Mm.
when I was writing code in that mode, the world disappeared and it was just me and the computer, and I was making the magic happen through my own skills, ability to type fast, because I taught myself to type quickly when I was pretty young. And all of that almost doesn't matter anymore. You might not get to do that as much anymore. There's no one preventing you from doing that, but certainly in the workplace, if you can just get an AI to generate at least all the boilerplate code for you much, much faster, why wouldn't you? Why would your employers say, yeah, no worries, just type it out slowly, it's okay, we'll prefer? No, it's for sure that Pandora's box has been opened, the genie's out of the bottle. These tools are here, they're here to stay, and they are magical, but they replace a part of us that I think a lot of us quite enjoy doing. So diving into that, I started thinking more about, so what does that really mean though? So fine, perhaps we're letting go of something that meant something that we tied ourselves up with. But by the same token, some of us have already experienced changes like that in our careers. And upon reflection, I have, by becoming a manager partway through my career, very reluctantly, because I really enjoyed the coding and I didn't want to move away from it. I thought, is there a parallel I could draw there? And the more I thought about it, the more actually maybe that's the angle to lean into, to realize that you don't need to choose one or the other. There is the engineer manager pendulum that Charity Majors talks about. So maybe here there's something similar that we can swing between the two sides. It doesn't have to be one or the other. Finding that balance might be the right approach for many of us, at least. And yeah, so all of that resulted in a very long blog post. And to be honest, it's a lengthy one, but I clearly had a lot to say.
Yeah, and it's been very well shared. And I guess that experience that you had, I guess, with moving from an engineer to a manager clearly brought back some memories there from when you started using Windsurf or other tools. It brought back memories from, I guess, when you did move from engineering to a management role. Maybe there's others actually, listeners, who have done that similar move and stepped away from the day-to-day coding much more. I guess that was presumably your inspiration, your motivation for building the post. What when you moved from an engineer to a manager, I guess when you manage a team, it's slightly different. Perhaps you're even further away, maybe more managing a project versus having more of that creative aspect. And there are going to be, I guess, there's probably two different styles of roles there in the management of engineering teams. One is probably more hands-on. One is more kind of like maybe the project management. So there's probably people who are more hands-on and more hands-off. From the development side, when you're now using AI tools, how much enjoyment do you feel you lose moving more to a prompt based way of developing? Do you have that real connection to writing code, or do you still feel like there's a level of creativity, a level of feedback that still provides you with that need, that that thing that we desire in terms of actually being able to create, build, and achieve something through building code?
Yeah, certainly think that there's still an element of creativity. Like it's probably more in the eye of the beholder, right? So it depends on what it is that you personally, as an individual, enjoy out of building solutions. I'm a problem solver. I enjoy doing puzzles of any sort. So for me, using these tools, there's a real positive aspect, which is I get to see a result much quicker, because let's face it, this sort of stuff that I'm using it for in my own home projects and helping me analyze some of the data that I'm collecting as part of my master's, time is of essence. And the quicker I can get something up and running, the better for me, the sooner I get the insights and stuff. But if I think about the switch from being a software engineer to moving into management now, I don't know if I'm unique in this way, but there was a time when I wasn't even that far into my career. I want to say maybe 5 or 6 years into my career, thinking of a career as like a 40-year long thing. 5 years isn't long, right? And already I had people saying, you might like to consider a move into management because you've got some really great soft skills. And I think you'd make a great manager. And I just No, this is not why I became a software engineer. I like building code. I like working directly with the computer and like solving the problem myself, having that sense of accomplishment, that satisfaction of seeing something build and then working out that actually there's a better way I can do it. It's a very personal thing that you're doing one-on-one with the computer, right? I didn't want to give that up, not so early in my career. And I had a bit of pressure from various managers to consider a move into management. And I kept it at bay until about 10 years into my career when I finally realized that I had reached a point where I wasn't really learning all that much more about how to write better code. Writing the code didn't seem that hard anymore. I could do it. I knew I could do it. I was teaching myself other skills like how to debug memory leaks and just trying to get into something slightly deeper, something slightly more complex. So eventually I came to the idea that, okay, fine, I will try being a manager because there's no doubt some skills that I might be able to learn there. But then that transition is quite hard. And I don't think many companies recognize that taking someone who was a pretty good software engineer and then moving them into management, it's not always a smooth transition. And it's something
Yeah.
that I talk with a lot of people when I'm interviewing for other managers. If this is their first foray into management, I always ask them why. What is it that's pushing you towards this? And, there's always a variety of answers, but I make sure that they understand that in a management role, you're going to have different priorities and you're going to spend your time on different things. So if the job description implies that you might still get to code 50% of the time, that's unlikely to happen. Like, as much as you might want it to happen, managing people or projects or anything that's more wetware is is a whole different ball game. It's a different set of skills. You're leaning into communication skills, into a bit of empathy about understanding the relationships between people, the strengths and weaknesses, and how you pair up people so that you create opportunities for people to learn and do their best work. So you're really learning quite a different skill set that you're practicing day to day.
And this is the identity crisis that you mentioned, because you say in the blog that we find our identity in building things, not managing things. And I think from the move from an engineer to a manager, very often, somewhat, hopefully at least somewhat, it's the individual's choice to move into management. So there's almost, they're trying to fulfill the
Yeah,
decision that they've made. With, if we draw a parallel to some of the AI tools and engineers using AI tools today, there are going to be people who are having AI tools forced upon them by, it's amazing. We're seeing a number of companies now that are almost like saying, yes, we absolutely want you to use this, and if you're not, you need to be telling us why you're not using these productivity tools,
that's
essentially.
right.
What can we learn from folks like yourself who have moved from an engineer to a manager role? How do we best, at least as we go through this identity crisis again, moving into an AI native world, or a software development world with AI tools, how do we best either embrace this identity crisis or at least manage it in some way whereby we can still succeed, even if we do or don't embrace some of the concepts of AI and software engineering?
Yeah, you're absolutely right. I was thinking about this earlier today as well, just that as a software engineer moving into management, theoretically that's a choice, whereas here perhaps won't have a choice. Really, I think what's important is to probably not resist it because, as you say, at sooner or later, you're probably going to be in a job where you're expected to use these tools and learn to use them really well because they're your new toolkit. Embrace the change because
Mm.
ultimately what it's doing is allowing you to build a new set of skills. And some of us get to that point in our career where we recognize, I did, that by staying in the same role that I'd been in for a while, I wasn't really gaining a whole lot of new skills. So maybe it was the right time for me to accept a sideways move into a management role where essentially I felt like I went back to being a novice and I was learning how to do one-on-ones, how to set up a hiring process and an interview process and how to do performance reviews and all of that, which was so different. I did not go to university and learn all of that stuff like I did the programming that I was taught. But by doing those jobs and setting all of that up and caring deeply about it, I learnt a whole lot of new skills that have come quite handy even when I've returned to IC roles. Just being able to see the world through the lens of what would my manager think about this, or why is my manager asking me to do this thing that feels to me like it makes no sense, But actually having been in their shoes now, I can understand better the perspective that they have. So you do learn so many new skills. So just accept that there's an opportunity to see it through that lens and build up a whole new set of skills around how to, not just how to communicate better, because I think that's one of the fundamental skills of getting good with these tools, but also a whole bunch of new jobs are going to crop up. The term AI engineer is now floating around. There's going to need to be things built around prompt libraries and specifications, how to write specs really well, or how to verify that the AI is outputting the right code or making the right decisions. We're now working with non-determinism, which is something that probably makes a lot of us quite uncomfortable. So how do we manage that? How do we accept that there's likely to be a lot of unpredictability in both using them as AI coding assistants, but also if we're building agentic systems. So suddenly there will be new areas of specialization that you can gravitate towards. So it's not like the door's closing, it's just shifting, and a whole new set of skills will become apparent as really important into the future. So I guess it's
Yeah.
being open to that change.
Yeah, and I think there's a couple of things there actually. One thing that you mentioned there is being accepting of that and being like almost very openly wanting to learn those new skills is super important, I think. We'll be faced with folks who are just coming into the industry who are ramping up on these skills so fast, almost like it's the way versus a change. And there are individuals in the industry who have been in the industry for many years who are going to be at a disadvantage somewhat because people are jumping into this AI space so fast. However, those people have a massive advantage in understanding and knowing how software is built from the ground up. And we were talking about this off air, and you mentioned about going through that experience of there's an issue in prod. We need to understand why. We need to learn the lessons essentially of everything from bad code to bad design, bad architectures as to why these things happen. And so people who are in the industry now have that unique knowledge of, I guess, that mechanical sympathy of how things work under the covers, as well as the opportunity to learn about the new AI technologies on top. And that's going to probably be fairly unique somewhat in many years to come, having that in-depth knowledge.
Yeah, and I guess there are parallels in history. Like I mentioned, the Industrial Revolution, which obviously I wasn't around for. History repeats itself. So I think there are instances like the one that I mentioned, but also I wasn't around when compilers were introduced. But I imagine that the generation of engineers that were halfway through their careers when that shift happened, they also had to learn to trust this thing that was now outputting the code that they previously had to write by hand and understand intimately. There would have been, I'm sure, lots of criticism on the compiler cannot possibly create assembler as good as I can and all of that. Or how am I going to know how to debug it because I didn't write it? So there are lessons we can look back on and see how did they work through that shift and how were they either at an advantage or a disadvantage, and what can we do to help those that will find it more challenging for a variety of reasons. Actually, on that topic, I came across a very long 290-page World Economic Forum on skills and the job market, and looking forward to 2030. Seems like a long way away. It's really not. But it's a huge document, so clearly I have not read it all. But what caught my attention was this sort of quadrants on what skills will become more important or less important. And the one that sort of stands out as the most important, well, it's currently already important and it will become more important, was resilience, flexibility, and agility. So those are the sorts of like really core skills. Do we teach that in schools? Is that something that you can go to university and study? This is what makes this shift so interesting, that a lot of the skills that appear to be becoming very critical are things that you mature into. And that's where my conundrum is. How do you teach those? How do you short circuit that experience-based deliberate practice learning process and moonshoot right to you're already critically thinking, you are thinking at a higher level, you have this holistic perspective. That's the right hand side of the Dreyfus model, where you've reached a level of expert and you're functioning from a level of intuition. How do you build intuition if you haven't lived through it? So
Yeah.
that's the big question mark for me.
Yeah, very interesting. in the blog, you talk about shifting roles, which is obviously a big part of the post. And you mentioned going from effectively builders to managers, from creators to orchestrators, instead of writing code to managing AI systems. You reference actually Patrick Dubois, who wrote the four patterns of AI native development, which is still something that is very much up for community involvement and contributions. Patrick talks about going from implementation to intent, from producer to manager, which is obviously very aligned with your post, from delivery to discovery, and from content to knowledge. We'll link both of these posts in the show notes as well. But in producer to manager, which I think is most relevant here, Patrick talks about the fact that, first of all, in fact, there's a few things here that are probably quite relevant. He talks about AI produces the code, you review the code. And I think that's a problem. We're not good at reviewing other people's code anyway. So this is going to be, we'll talk about this a little bit in terms of how much of a skill we need to really build there. I guess fun wise, creativity wise, how interesting that's going to be. Patrick also talks about the cognitive load reduction, which is interesting, talking about how AI can effectively give us contextual annotations and explain much, much more of what code changes are happening versus perhaps a diff with red and green highlights. Acceptance fatigue, which is a big problem. And I think this happens a lot with code review, but will very much likely happen. I do it a lot more than I wish to admit with Cursor and things like that, where it worked the first few times. Let's just keep accepting it and trusting whether it does that. Is that a good thing as things become reliable enough? And of course, the situational and awareness. Effectively, when something fails, can AI help us with that? Because if we didn't write that code, it's hard for us to be able to identify where something went wrong. So yeah, you cover this very lovely, very beautifully in your blog as well, with creators from writing code to orchestrators, which is effectively managing those AI systems. And you talk a little bit about reclaiming responsibilities, doing more design work and systems thinking and things like that, which today is a very specialist area and specific people do that. So I guess let's take that a little bit from the top down. I've mentioned a few things there. First of all, if AI is producing the code and we review it, what's the fun in that, Annie?
Yeah, that's a really great question. And you're right, we don't make great reviewers. I know as a software engineer or even as a manager of software engineers, that begging people to please review your code. You've got this PR, you'd really like to get it merged in, but it's a bit long and I'm sorry about that. I went overboard with the refactoring. It's hard enough to do that when you've written all the code yourself, so there isn't just screeds of it. How do we make it fun? Whoever solves that problem will probably be quite a rich person. So I love the ideas that Patrick writes about with the better than just the green and red diffs. Yeah, thinking back to the days when we didn't even have great diff tools. I think that the trick with using these tools, and it's something that I mentioned to people who are just starting to play with it, is source control is your friend. Like frequent commits, frequent PRs, because it can just get away from you. It sounds like you've experienced that a bit yourself. Like before you know it, you've changed 18 files in ways that you didn't expect to, and now it's becoming a bit overwhelming, even for yourself, to know which ones to pick for your PR. That's not a great state to be in, because you're going to end up committing stuff that, well, if you're honest with yourself, you probably haven't really checked. And then the next person in line who reviews your code may not really check either, because vigilance fatigue is a thing. And yeah, that's going to become a bigger problem, I imagine. And I think that the 2024 DORA report already starts to point at that. They've shown that for all of the productivity gains and even the increase in code quality, we are seeing a slight decrease in that delivery stability. And that's potentially attributed to the fact that PRs are getting bigger. People are just accepting code that may have more issues in it, and therefore there's a bit more code churn, where we're seeing an increase in a more recent Git Clear report that I mentioned in my blog post. It showed some pretty staggering figures on code duplication and increases in code duplication, increases in that code churn, code that's released and then has to be quickly modified and re-released, likely because it had a problem in it. So yeah, I think the DORA report will be an interesting thing to keep an eye on over the next few years as we go much faster, but are we more productive if we're actually just rolling back code more often and having to redo the same bit of work and like probably producing a lot more code, but maybe not in the ways that we thought we would gain the productivity? We're gaining productivity here and then losing it here. You're just
Yeah.
shifting your focus.
Yeah. And I think over time as well, over time, we're going to be, if we're stepping away from code that much, are we the right people to actually decide what good code looks like? Or do we actually need to have much more of a reliance on testing and autonomy to be able to say, irrespective of how good this code is, it is doing the right thing or it's not doing the right thing? And
Yeah.
yes, we can do things to make things more performant and so forth, or maybe refactor it to be more maintainable, better looking code, but we know it's doing the right thing or we know it's doing the wrong thing. And I feel sometimes actually the review almost needs to be more focused potentially around the correctness versus the style, which I think a lot of reviews typically over rotate on. So yeah, I wonder how much of that can be automated out through much better testing, which we, I guess, historically have never been great at, but we need to rely much more upon it because that's probably far more interesting than actually sitting through looking at code reviews.
When I do code reviews, I don't do code reviews in the sense that I am the only person reviewing code, but I still read through code because one, I find it interesting, and two, it's the closest I'm going to get to the truth. Like when
Yeah.
somebody says, "Oh, we solved the problem," rather than asking them to describe it to me if they're busy, I can probably just go look at the code. And over the years, you get pretty good at recognizing the shape of code.
Hmm.
That's what I like to refer it as. If I see it on a page, as long as it's relatively well structured code, you can pretty quickly recognize the flow. And I guess that's maybe a skill that we will need to build into one another. How do you get good at recognizing which parts of the code you should spend more time reviewing for that element of correctness that you very rightly pointed out? Because testing is automated testing, absolutely verification. Today I came across a blog post that talked about product managers now starting to focus on this idea of building evals
Hmm.
as a sort of analogy to unit testing, which was for
Mm.
more deterministic systems. Product managers who are perhaps looking to build very cool agentic systems that can book a flight to wherever you ask it to on your behalf. Please find me a great weekend getaway somewhere around San Francisco, and off it goes, except half the time you end up with a flight booked to middle of nowhere, and that's not what you asked for. So how do you prevent that from happening? Well, they're starting to come up, much like we've started to talk about spec driven development and stuff. Product managers are talking about this concept of evals, and that's evaluating that the output was in line with what they expected it to be. And I don't know what sort of tools they're imagining, but you start to see the importance of that safety net, the guardrail, that, the more automation you can put around that, the better, because otherwise we're all just going to become AI babysitters, just watching its output and preventing the things to leak in ways that we don't want them to. And I'm not sure that there's as much joyfulness in that type of work as there is in being the creator.
Yeah. Yeah, no, I completely agree. I completely agree. When we think about skills that developers are gonna need to be successful and to be that creator, we talked about some of the kind of the flexibility, the ability to change those types of things. From a skills point of view, that is more specific to development, whether it's things like, I guess, prompt engineering and things like that. What do you feel are the things that are going to probably be hardest to let go of from a development point of view? And perhaps there's some analogy here to, I guess, moving from engineering to management. And once we move away from them or deprioritize those, what do you feel are the most important skills that we need to grow to be successful as an AI assisted developer or an AI native developer?
What that makes me think of is, I don't know when the last time you sat an interview for a software engineering role yourself, Simon, but we still tend to ask a lot of very, very detailed questions. So I'll tell you a little story. I interviewed for a job at Google when I was about 3 years into my career. It was my absolute dream to work for Google, and this was before the days of video conferencing, so it was literally over the phone. I had to hold the telephone up to my and try and solve some very interesting puzzle brain teaser questions. I guess it was just before the days of elite code, right? Needless to say, I didn't pass that interview. Eventually, I was offered the job, but it was not in the domain that I wanted. It was a software engineer and test, and I had an issue with that. And that's for another blog. But throughout the years, I've noticed that we still quiz software engineers on their ability to solve these sorting algorithms or search algorithms or like recursion. Can you reverse a linked list? Like the industry still believes, and maybe it's changing now, but we have until now still believed that those skills are absolutely critical to you being employed as a very skilled software engineer. And then I'd say 90% of the time, you join the company and you don't get to work on things like that. You are stitching together libraries that someone else has written the fancy sorting algorithm for. Why on earth would you go and write your own? Unless you work for Google, and you're probably not going to be building the next fancy sorting algorithm from scratch. And it means that there are literally people who enjoy going through those sorts of lead coding exercises. There's a reason that website exists, right? There's leaderboards of people who can solve the most complex problems the fastest. So that I don't think will be very important anymore. That's a skill that a lot of software engineers have taken to be the core of being a really strong software engineer. That is a skill I think we're going to need to learn to let go of, both in interviews and personally. It won't make much sense anymore. Why would you need to be an expert at writing that level of code when an AI can probably generate something good enough for you?
That alone leaves a big gap, because when I think of that, I think of a really, even today, like I'm not close to product code, let's say today, but I think of those kind of things as it's challenging, they're problem solving, they're interesting problems to solve. Do we have a replacement for that, or do we need to learn to love other challenges?
I think it's going up a level, like in terms of a level of abstraction, perhaps. I think it's still very important to understand how systems work, how they interact, where your interfaces are, and how to make sure that you protect parts of the system from a resilience perspective, a SRE. These concepts are still important, but do they give you that dopamine hit that you get when you finally get that recursion to work the way that you want it to? I'm not convinced it's the same. So I don't know exactly what you would replace it with. Maybe for fun, you might still go and do some of that type of work, but that's going to diminish it. It can't possibly not. I suppose there might still be some people that enjoy writing a bit of assembly just because it's something that they enjoyed doing a few years ago, but it's not something that you probably need to do for an interview or in your day-to-day job anymore. So that's what I mean. I guess this is where the identity crisis blog post, why it meant so much to me, because there are some gaps there that I can't square up. I can't see precisely how we're going to get quite the same type of enjoyment out of this type of role. But certainly knowing for the foreseeable future, there is still going to be plenty of work in understanding systems, knowing how to hand code or hand change code, because software is everywhere. It's embedded into everything, and we all know that there are still older systems that run on very old technology, old programming languages. There are still plenty of COBOL developers out there who are gainfully employed, and I'm sure that 30 years ago, someone was probably thinking that was a time limited offer. And yet here we are in 2025, and I'm good friends with a few. So I know that things will change. Some things will change much quicker, and some people will move with that change quickly, and others will take their time and perhaps really find a niche for themselves in being able to leverage those skills. But yeah, this is what makes
Yeah.
this entire topic so fascinating and so quickly evolving.
Yeah.
What
And
we're talking about
incidentally,
today may not be valid in a week's time.
yeah, very true, very true. Incidentally, those developers are very well paid as well. Those,
Yep.
yeah.
So,
Um,
I mean, maybe we've got something to look forward to.
there we go. There we go. So you mentioned systems thinking. Those that like when we think about that level of abstraction, we're thinking more about the architecture, more about the systems, more about the interconnectivity between those apps. Are those going to be more of the skills, I guess, from an application point of view, that we need to either grow or recognize we need to spend more effort in? Because I think those are some of the parts that actually make the applications that much better, because it has a greater impact in very often with how they actually work and how they run and how they work with each other and how they're maintainable.
Yeah, how successful they are in the end, right? They even solve the customer problem that you were trying to solve. That's where I think the other part of that blog post and another one that I've written as well comes into play. Something I noticed during my career, and I suspect there's many factors at play here, but when I went to university and did my comp sci degree, I was taught the whole software development lifecycle, from eliciting requirements by interviewing customers, understanding what the problem they were trying to solve was, trying to steer them away from telling me what they thought the solution should be, working through use cases. At the time, UML was still quite popular, so modeling it all using UML and working through some scenarios for each of those use cases, and then thinking about all of the testing that would need to be done, the different types of testing, all the edge cases, and then building it and applying all the testing thinking, and then maintaining it and upgrading it and all of that. So the full end to end. I was lucky enough to do all of those things in a number of the jobs I've had. And part of it might be that a lot of the jobs I've had have been at smaller companies, either startups, like quite small startups, 10 people, even less in some cases, up to scale ups with 400-ish people. And in those sorts of organizations, you tend to wear a lot of hats. Whatever needs doing, if you've got either the skills to do it or the interest, or there's no one else. So you end up exercising those skills and practicing them and learning as you go, and you build up this holistic picture of what it takes to build a system like this.
Yeah.
But throughout the years, what at least I feel like I've noticed is this huge demand for software engineering, because, like I said before, software just runs the world now, doesn't it? Imagine a world where you don't have a mobile phone in your pocket with constant internet and all the apps that you rely on today, the games you play and the media that you spend too much time scrolling through. Imagine a world without that. It's really hard to imagine, but software runs all of that. So behind the scenes, there are all these software engineers busily building up all of these systems that we just take for granted today, right?
Yeah.
So that has meant a huge increase in demand for the ability to build software. And no matter how hard universities tried, they still weren't pumping out enough graduates who could do the job. So I think what ended up happening is we recognized as an industry that we needed to apply a bit of specialization here. So of those who went through the appropriate level of education, whatever that means in the context of the individual, you now get to focus on coding because no one else can do that bit. You should do the coding. We're going to get someone else to design it. We'll give that to an architect, and we're going to get someone else to understand what the problem was. That's a product owner or a product manager. And we're going to get someone else to test it for you, so you don't have to waste your time on that. It's someone else's job. And we'll get operations. They're going to deploy it for you and run it, and they'll be on call, so don't worry about it. And this isn't the case across the board. I know that there will be many engineers out there who do the whole gamut, like I described before, but there are equally a lot of us who ended up working in roles where we were just coding. That's all
Yeah.
we were expected to do, which means that we haven't had the opportunity to practice those other skills as much, that they are someone else's job, and those people have become very good at those jobs. So what happens now when AI is able to do the bit that we've specialized in rather well and a lot faster than most humans can type, then we need to start looking a little bit broader at some of those other areas that previously some of us got to do. In that sense, learning how to elicit requirements, that's probably a really good skill to start looking for opportunities to practice and to learn. Is it quite as enjoyable as reversing a linked list? Maybe not to everyone. There will be value in that. And architecting systems, that's the technology career ladder, or the software engineering career ladder, seems to put an architect kind of at the top of the food chain, right? Like you have to have gone through all the hard yards before you get to be an architect. It doesn't really make sense to come out of university as a software architect. You haven't felt the pain yet. You have to have lived through working out why that architecture just doesn't make sense. So how do you teach those skills without having had that background? Again, we're back to the beginning of the conversation, that it's hard to even fathom how you're going to learn those experiences. But at least for anyone who's currently a software engineer, start looking for opportunities to think about the bigger picture, the architecture, the system design that fits best in this particular use case. Wow, if you're going to start looking at agentic systems, that's a whole new area that there really aren't that many specialists in yet, because it's such a new domain. And systems where you're actually using an LLM as the orchestrator that decides for itself which tool or skill to use next. How do you even test that? Because now it's non-deterministic, and we're not very good at thinking through non-determinism. It's that unpredictability is a bit unsettling. So
Yeah. And the more we go down that avenue, I think trust becomes a massive deal, particularly because when we're thinking about agentic and taking on greater tasks, it'll be interesting. There's definitely a journey that we need to go on here with trusting results from LLMs. It's amazing, actually, just in the short time that LLMs have, or AI has really been more mainstream in the last couple of years, how much more, or how much less, should I say, trust and security is talked about in general. I remember it was a case of, oh my gosh, we can't use this in our production environment, so we need to go through the CISO first to work out whether we can use this tool. These days, it's, oh my God, people are rushing to try and work out how they can make those productivity gains from whether it's from the board, from the top down, the CEO down. But I think as we get more autonomous with our development, I guess what is the trust dynamic in terms of us, first of all, understanding whether the code is doing the right thing, but secondly, us stepping away from that code. We can only step away from that code if we truly trust the AI that is generating that. What do we really need, do you feel, to actually truly trust this process?
So the research that I've seen on trust is emerging. I would say that there was a lot more research, or there has been a lot more research around the productivity gains, which is probably why, as you say, so many companies are tripping over themselves to get in on that action. But the trust aspect, what I've experienced it a bit myself, right? These through just using these tools, but you have the sense that expectations are pretty high because you've read about it, your first experience with it was pretty good. So you've got pretty high expectations, but then the unpredictability of it starts to erode that trust, and it's
Mm,
hard to rebuild it. Whereas with humans, you start off with less trust, but you build it up over time through interactions. I remember doing a lot of reading about this when I was trying to be the best engineering manager that I could be. How do you gain that trust sufficient to be able to give people constructive feedback? Because no one really likes to hear constructive feedback. People say that they want all the feedback because it helps them grow, and that is absolutely true. But it can hurt to hear something that you've not done well or that you could improve. And so, how do you get better at giving that type of feedback? The trick is you need to build trust. You can't just give feedback to someone who you have no relationship with and expect that they're going to take it on the nose. They're just going to accept your feedback, and you're a nobody to them. But if you've taken the time to have, I think it's something like 3 positive interactions with somebody, then you're more likely to have a positive interaction about giving them some feedback. So that's how humans build up trust with one another. And hopefully over time it increases and you learn to finish each other's sentences. And if something happens to break that trust, you can rebuild it through a lot of effort. With AI, it feels a bit different. Like you start off maybe having a lot of trust in it, and then you hit a brick wall when it's going around in circles and producing something that's not at all what you asked for, and you're telling it that's not what you asked for, and it's agreeing with you because it doesn't signal that doubt, right? That's one of the main reasons why that trust erodes, because it's so confident in telling you the wrong thing. And then all
mm,
you have to do is ask it about it, and then it changes its mind completely. And you're like, no, I was just asking a question. I didn't expect you to go and undo just
mm.
stop, please. And so that trust is really important. But how do we build it? So actually, I read a very interesting paper about something that Google researchers are calling Seamful AI. So I'm not sure I'd heard the word Seamful before, but if you think about, most of the time we're building seamless experiences, right? We're trying to hide away the seam so that you're not even aware of it. But what this paper talks about is maybe that's the wrong approach. Maybe to increase creativity and confidence, what we actually, in using particularly AI coding assistants and software engineering, maybe what we need to do is actually highlight those seams and use them to our advantage. For example, one of the use cases they suggest is in those cases where the AI is not confident, it should not pretend to be confident, and it should tell you,
Mm.
Here's my opinion on how you could use some code that would solve the problem, but I have a confidence rating of 20%. And that could be an indicator to the human in the loop, the developer, to go, this is one of those situations where I need to take over a bit more and not
Yeah.
just trust the AI. For boilerplate stuff, it should have a confidence level of much, much higher because it's just boilerplate code. There's not too many different ways to solve that problem. So go for it. So maybe you can calibrate that trust through these very intentional, subtle hints.
Equally, code reviews then can really be focused on the areas where it has least trust rather than try and spend your time equally across a code review, the areas that are probably highest risk and also lowest trust from the AI. So those are the areas that we as humans can work together with AI to make it more solid.
Another paper that similar group of authors had written about was that they found, upon interviewing software engineers, that creativity in software engineering isn't necessarily what you think it is. It's not all about something totally novel. It's about building up a novel way of stitching together existing components and libraries and frameworks, like essentially finding novel ways to reuse and put together bigger systems from existing components. In terms of creativity, then, in order to encourage creativity, perhaps in those more complex pieces of logic that you're getting some help from an AI coding assistant with, from it, if it has multiple ways that it could solve that problem, some of which might encourage reuse, for example, then it could give you more than one option and explain why in some cases this would be better for reusability, and in these cases you might prioritize these aspects of it, and really highlight that there are many choices to be made here. The AI is not going to make that decision for you. You get to make that decision because that's how you express your creativity. Through that interaction, perhaps a bit more trust is built as well.
Yeah, yeah, I like that. I would trust if if LLMs gave me multiple options and I chose the right one and I could see its, I don't want to say thinking, but I could see its process, that would fill me with more trust, being able to say, actually, yeah, this is good. And I would actually feel more ownership of that as well, which is probably another important thing. So I guess as we think about the identity pendulum, as you mentioned, Charity Majors refers to it, when we think about the potential careers that could exist in this world whereby we're changing identity, I guess, do you still see a software engineer being even a title? Do you feel there are going to be various flavors of software engineers? Let's get the crystal ball out and try and think of what we think maybe software engineers in the AI era, what the job looks like.
Yeah. I think we're going to need to become very comfortable using AI. So I think we probably some of us might take it for granted that it's just like talking to another human, because actually there's a lot of similarities between interacting. If you're prompting, if you're chatting with an AI, it really is like talking to another human. And in fact, in my research, what I've seen is when people are asked, like, how would you improve your prompt engineering skills? A lot of answers are around improve your communication skills, lean into that. Some people think of it as a more formal means of communication. Some think it's actually just like talking to one of your colleagues and explaining to them how you would like something done. Maybe getting good at writing, maybe getting good at teaching and leading in that sense. In terms of, yeah, if that's the role or a lot more of that role, then are you still a software engineer? I think the role will be around for a while to come, thankfully, because, like I said earlier, there's still so many systems that need the skills that we have today. But learning how to use the AI, a variety of AIs as well, because they have their nuances, right? Different models even have their nuances. The Windsurf and Cursor are quite different to something like GitHub Copilot, although it's catching up. And then there's the multimodal AIs that you can use to generate images and stuff. So getting good at using a variety of these to supercharge yourself, I think those are skills that any individual, really, not just software engineers, but any individual should get good at. And then beyond that, I think, honestly, think through the new problems that will be created as a result of working in this new way, right? Because inevitably over time, we're going to be writing code faster because that vigilance decrement that we talked about, the just produce more. And so we're absolutely going to see, as we're already starting to see, code take a different shape and perhaps a little bit less stable. So maybe focusing on the tooling that would help identify those problems before they happen, highlight where, imagine being able to look into a software solution from the outside in and go, this version that you're about to release to production has more change in it than I think you realize. Are you aware of the fact that this business logic has now changed? And maybe that's a new tool that no one's built yet. So that could become a whole domain that people start focusing on. That the test automation is, we have a vision of what test automation looks like today, but maybe if we start considering these evals, that's another extension of it, and there'll be tooling around that. So maybe you could become more of an expert in that domain. And so there will be new specialities that people can go and focus on. But I think that the critical thing there is imagination. I think that's probably a skill that we don't talk about often. It's odd to call it a skill unless you were hoping to become a children's book writer or something, and where imagination is critical. But being able to imagine something, that's actually where it all starts. If you can imagine something with these tools today, you can probably build a version of it. But you need to
and
be able to imagine it. So where do you get that curiosity and that seed of imagination from?
and very often being too deep in the weeds actually pulls us away from that. And I really like the analogy that you pulled back before as well, with the kind of architect role that today people actually do strive for, and it's seen as that progression from an engineer to an architect. And I think I personally see that as a potential future for an engineer, where they will still be that engineer, but it will be an architect role as an engineer. Yeah.
And I was just going to say one more thing. Much like during the Industrial Revolution, from what is written about it, those who were doing the job manually, some of them moved into roles where they really understood the tools, the machinery that could now do the job that they used to do, so that they could wrangle them, just piece them together, improve them, fix them when they broke. So at their core, LLMs are probably a special type of work that not every software engineer is going to become a data scientist, AI specialist. However, that's like the beating heart, I reckon, that's going to drive a lot of other systems, be it because that's the LLM is the orchestrator of an agentic system, or it's underlying a number of agents within your IDE or something. So understanding how those systems are pieced together, the telemetry, the observability, how do you wrangle a system that is non-deterministic in nature, that has at its core this incredible, like, computational brain that is making its own decisions? Become an expert at running those systems, which are completely different to the systems we run today. They're similar in that they're probably still going to use a database and they're probably still going to run on a server somewhere. But those things might remain the same, but the orchestration of it will be quite different. Learning to wrangle those systems and fix them when they break and be able to identify where the issue is, that will become quite an interesting job, I imagine. Maybe that's the architect of the future as well.
Yeah, and history's shown us time and time again how these kind of disruptive changes creates these jobs, exactly like he just said. And I think that's definitely the destination we need to strive for. Annie, thank you so much. I must encourage those who haven't read your blog to absolutely take the time to read through that, because I think it's beautifully written, but very poignant to a lot of the challenges that we all face right now. So definitely read that if you haven't had the time, or get AI to summarize it if you want to be truly AI embracing. Annie, thank you so much for taking the time. It was an absolute pleasure to chat with you.
Thanks, Simon. I really enjoyed the chat.
Excellent. And for those of you listening, please do tune in to the next episode. And if you haven't already, make sure you subscribe and like this episode as well. Thanks, and see you next time.
Thanks for tuning in. Join us next time on the AI Native Dev, brought to you by Tesla.